All right, greetings everyone. Welcome to the fourth part of the video for section 5.4. Continuing on with our studies of identities related to trig functions. And if you haven't already gotten the sense, doing trig identities is a lot of fun. It's really exciting, and I'm sure that every single one of you will look like this kid here as after you solve your first one by yourself. Okay, let's continue on with another example of proving identities. So here we're given sine squared of theta over 1 minus cosine of theta. We have to prove that equals 1 plus cosine of theta. And again, as I mentioned before, there's no common way to solve these every single time. But a generally good strategy is to start with the left-hand side here and try to make it equal to the right-hand side. Another strategy is to try to write, excuse me, everything in terms of sines and cosines, which we actually already have in this problem, so that won't be super helpful for us, but generally that's a good approach. Well, what are we going to do instead? Well, notice there on the top we have this sine squared, which anytime we see something like that, hopefully we'll get into the habit of relating that to our Pythagorean identity. So sine squared plus cosine squared equals 1. And since we just have a sine squared here in this problem, it might be a good idea to just isolate the sine squared here. So we could do that by subtracting cosine squared from both sides, which if we do that, these cancel. So now we have that sine squared of theta equals 1 minus cosine squared of theta. So potentially, for that sine squared over there, we could substitute this 1 minus cosine squared. And that actually might be a helpful thing to do because we see that everything else in the problem is a 1 minus or 1 plus cosine. So let's go ahead and do that now. So we're going to substitute this part here, the 1 minus cosine squared, in for the sine squared here. So now our expression there will become 1 minus cosine squared of theta divided by 1 minus cosine of theta. And that somehow has to become 1 plus cosine of theta. Now, your inclination to do that might be, well, if I do 1 divided by 1, that gives me 1. And negative cosine squared over negative cosine, well, minus and minus will give me a plus. Cancel out a cosine from the bottom with the top, and I'll get the cosine theta. Done, game, set, match. What else you got for me, Cody? Unfortunately, that won't work. Okay, we can't cancel stuff out that way because things are being added and subtracted here. So we need some other tool. And the tool we're going to use is something called the difference of squares. If you've taken Math 98 or Algebra 2 or even Math 141, you may have seen this before. And the difference of squares is something that tells us that if we have an expression of the form something squared minus something else squared, so a squared minus b squared is an example, that can be factored to give us a plus b times a minus b. Okay, so that will factor that way. And that can actually apply to the top part of our expression here. And if you're wondering how, well, first of all, you probably noticed that the second part there, the cosine squared, that's definitely something squared. Is 1 the same as something squared? Ah, that's right, it is, right? Because 1 is actually the same as 1 squared, right? Because 1 squared gives us 1. So notice we do have this format of something squared minus something else squared, which then according to this we can factor as 1 plus cosine of theta times 1 minus cosine of theta. Okay. So because that top part factors to that, we'll rewrite it as that. So this will become 1 plus cosine of theta times 1 minus cosine of theta. I should say cosine of theta, not whatever I wrote there. All divided by 1 minus cosine of theta. And notice now, because everything on the top, we have two expressions being multiplied. In this case, we can now cancel this 1 minus cosine with this 1 minus cosine down here. And again, that's because everything on the top is being multiplied. If it wasn't, that wouldn't work. Or those two expressions are being multiplied, I should say. And what we're left with is just 1 plus cosine of theta, which is what we were trying to find, right? We were trying to prove that that was equal to this. So we've done it. Good job. Does your face look like the kid from the meme? I can't see it, but I'm sure it does. Okay, one more thing from this section. We'll talk a little bit more about the Pythagorean identity. And sorry about that. So again, we'll go back to our cosine squared of theta plus sine squared of theta equals 1. And look at some other ways to write this. Okay. So one thing I'm going to do first is go through and divide everything in this equation by cosine squared. So this will become cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. And that's a legal thing to do because I divided everything in the equation by the same thing, so that's allowed. And let's see what we get when we do that. Well, the cosine squared over cosine squared, if you divide something by itself, that just becomes 1. Plus, if we do sine squared divided by cosine squared, recall that we had an identity that sine over cosine was tangent. So what do you suppose sine squared over cosine squared gives us? That's right, it gives us tangent squared of theta equals, and then we have 1 over cosine squared. And so remember, 1 over cosine is equal to secant, so 1 over cosine squared would give us secant squared. Okay, and there is an alternative version of the Pythagorean identity. So that would be another identity you may want to make use of as you're working on identity type questions on your homework or on future assignments. Okay, and again, we got that by dividing everything by cosine squared. So what else do you suppose we could do? That's right, let's divide everything by sine squared and see what happens. So we can make this cosine squared over sine squared plus sine squared theta over sine squared theta, and that equals 1 over sine squared theta. And if we go through and work that out, so in the first expression we have cosine squared over sine squared. From earlier in this section, we know that cosine over sine is cotangent. So cosine squared over sine squared should give us cotangent squared of theta. Plus, again, sine squared over sine squared, you're dividing something by itself. That just gives you 1 equals, and then 1 over sine squared. We know 1 over sine is cosecant, so 1 over sine squared would be cosecant squared of theta. And we again then have now a third version of the Pythagorean identity. So all three of these now are some identities you may want to incorporate in your toolbox to help you as you approach identity type questions. Okay, that's where I'll leave it for now. Thank you for watching.